Okay, let's start with solving the two problems that we did last night. Real simple, ordinary differential equations, and we'll turn them into Simulink models. This first one is y prime equals f of t with y of 0 equal to 0. We're going to let f of t equals 0 for our first case, and that therefore y prime equals 0. So dy dt equals 0. We integrate, and we end up with y equals a constant. Since y of 0 equals 1, the constant equals 1. And our final equation is y equals 1. You'll see I did the same thing over on the right-hand side with Laplace transforms. So you can be thinking about that as well, because basically Simulink is based on Laplace transforms. The second problem we'll do is y prime plus y equals f of t, and y of 0 equals 1 as before, but this time we're going to let f of t equal 1 too. And we're going to solve this using, there's a number of ways we could solve this, but we're going to use an integration factor. We multiply both all the way through by e of t, our integration factor, and it makes it easy to solve this. We integrate both sides. We get y e of t equals e of t plus c, y equals 1 plus c e of t, and in the end we end up with y equals 1. We do the exact same thing on the right side with Laplace transform just for your benefit. Okay, so let's go ahead and bring up MATLAB, and let's do a new Simulink model. It'll take a second or two for this to come up, and we'll just build those exact same two models into our Simulink model. I'll set this over here, and we'll bring it up as needed. So here's the Simulink window. Okay, we'll expand it a little bit to make it easy to see. And I kind of want to see the library browser. Now, the library browser has a bunch of different functions in it, but for now, we're just going to stick with a couple of the basic library functions. Okay? In fact, it's mostly, for the most part, it's the commonly used blocks. Okay, we're going to need an integrator because we're going to need to integrate that y prime, so we're going to use an integrator here. Okay, we're going to need, let's see, what else are we going to need? We're going to need an input constant. That's our input into the system. That's our f of t. Okay, and we're going to need something to show what the results were. So in this case, this is pretty much, oops, that's a floating scope. I don't want a floating scope. I want a scope with a connection to it. There we go. Let's go ahead and connect these up. In our integrator, we have to give our initial condition. In our case, it was 1. Okay. And our constant actually is 0. We're inputting 0 to start. F of t is 0. Okay. If we open up the scope, we'll get a little scope here, which is a graph, basically a graph. And if we just come over here and click on this, okay, it should be equal to 1, and sure enough, it is. Okay, so we've done that problem. So let's look at our second. Okay, thank you. Let's look at our second problem. Okay, let's go back here, and we'll modify. Let me just save this. I'll tell you what we'll save as. We'll call it, and I'll upload it for y'all. Let's see, classes, class 8, and let me just create a new folder, and we'll call it class folder. Great. And we'll call this Simulink. Okay. And I'm going to save that and load that so that you have it. I'm going to go eat a hamburger, and then I'll come back and I'll do the second half of this.